All right, so as you guys know, we're going to be doing everything online now, which really shouldn't change a whole lot for our biochem class because you guys have already been doing most of the notes online. The biggest problem is likely to be um, the fact that I'm never there for you guys to ask questions. So we're going to figure that out together, whether it's through emails, pictures attached to emails, whatever. We're going to have to get those questions answered, excuse me, and who knows how that's going to work out. So let's just keep doing what we're doing. Last thing I had you do was cover a couple reactions for alcohols. You covered that acid-base reactions and the combustion reactions. This slide specifically is something that would have been just skipped over, right? So I put it up here. It is important. But as you're going to find out as we go through, I'm going to cover with videos some of the most important things, the hard things. Little things like this, you could fill in from the PDF that I'm going to put up for this whole chapter. Right? You know those PowerPoint slides that I usually use? I save those as a PDF. I'm going to post those online so you can get with whatever's missing. Right, so be patient with me. If I skip around a little bit, you can just kind of fill in as you go. Right? But phenols do have uses, as you can see on this slide. They are used as antiseptics, disinfectants, but we substitute them now because they don't smell as bad and they have less adverse effects. So it should be kind of self-explanatory anyway. But really what we need to cover in this notes are ethers and thiols. Right? And I'm going to do both of them as quickly as I can because they're actually fairly simple. What you need to know is simple. So an ether is an organic compound that has that oxygen, but it's an oxygen bonded to two different carbons. So this is an ether. Right? I have what looks like a 5-carbon chain, but I replaced one of those carbons with an oxygen. Right? So really there's 4 carbons in this ether here. Right? It will have some kind of formula that goes with it. Again, essentially you have 4 carbons here. You have what looks like, since it would be 4 carbons, and the oxygen just kind of counts like the connection between. So if you just double and add 2, it should still work. Right? There should be 10 hydrogens on those 4 carbons, and then there's an oxygen, right? Sometimes that formula would be written differently though, because really it's a, CH3CH2O CH2CH3, right? That oxygen's kind of in the middle of those 2 ethyl groups in this molecule. And so it just depends on what the look is, what you're supposed to see. But also, if you look below, right, that R group can be anything. I can even connect to a ring. So I have a lot of different ethers to look at. But that first one, that happens to be a diethyl ether, right? It's also the real ether, the original ether, right? So if you say ether, a lot of times people are referring to this specific ether. But again, it could look different because it could be an ethyl and oxygen and then put like a cyclopentyl on there. That'd still be an ether because that oxygen is connected to 2 different carbons. Naming these things is actually a non-IUPAC common naming system. We do use those alkyl groups from what we talked about before, so it should be pretty simple. Again, I'm going to call this thing, the original one we drew up there, a diethyl ether. Essentially, I have 2 ethyl groups attached to that oxygen. So ether is just the name that I'm going to use at the end. It's a diethyl ether because I have 2 ethyls attached. Otherwise, I could also have a dimethyl ether, right, which would just have 1 carbon attached on each side of that oxygen. So pretty simple, pretty easy. I can use methyl, ethyl. I could even turn it into an isopropyl, right? So, and cyclopentyl like I had on that last slide. So it's actually fairly easy. Just make sure you use that prefix if you have more than one that are the same. It's always going to be a di because you can only have 2 different groups attached to that ether. So it should be pretty easy to name those things. Again, that very first one, the diethyl ether, sometimes is just referred to as ether, literally. But that's because that was the first one, essentially, that we really talked about. Properties and reactions of ethers. They do have weak dipole-dipole interactions. Boiling point similar to hydrocarbons, similar size. Small ethers are water soluble. Again, the more carbons you have, the less likely it would be to be water soluble. They are typically good solvents for organic compounds, but they're super flammable, which is actually a use that maybe some of you guys know of already. Ethers can be used to prime engines to actually, because they're flammable, make that combustion engine turn over a little bit faster. So in terms of reactions, combustion is going to be the major one. So if I took that original ether again, and I wanted to burn it, I can definitely do that. I'm going to make the same products as always. I'm just going to make carbon dioxide and water. It's just going to balance appropriately. Again, the hardest part there is probably going to be figuring out how many carbons do I really have. Remember, it was 4 carbons, 10 hydrogens, and oxygen. And this was also something you should have learned already, a situation where when you burn this, there's already an oxygen in that ether. It changes the rules. So now I actually like having an odd number of waters. Doesn't hurt, right? So if I have this to balance already, I could see already that I'd have 5 waters with that 10 hydrogens from one side. That's actually okay, because I'm going to have an odd number of oxygens on both sides. So balancing it the rest of the way, 4 carbon dioxides should give me 8 plus 5, 13 oxygens total. 12 of them are from here, and 1's right here in that ether. So that should be balanced. Just make sure you can do those combustion reactions with oxygen. Otherwise, the other use for an ether is an anesthetic. Right? That ether that I talked about, that first ether that I keep going over and over again, diethyl ether, was originally used as a general anesthetic. Right? So you would actually breathe that in, it would knock you out, and the doctor could do a surgery on you. We don't use those anymore because they're explosively flammable. So, and there's undesirable side effects. You can be a little groggy for a little longer than we want you to be. Right? So actually now we use halogenated ethers or halogenated hydrocarbons, which we'll talk about later. In reality, anesthesiologists use a wide variety of different chemicals at the same time to put you out. As you can see here, it lists anesthetics, sedatives, muscle relaxants. That they have a lot of different things that they put into you because they don't want you moving while you're getting your surgery done either. So I don't know if any of you plan on being an anesthesiologist. I can't even say the word right now. But they are very high-paid doctors for a reason. They are actually the most likely to be sued because they're actually the ones that are most likely to kill you. Right? Any surgery carries a risk, and the biggest risk comes from being put under. It's not from the surgery itself. So they have to pay really high medical insurance fees because they're actually the most likely doctor to kill you. So high paid, but for a reason. They know what they're doing.